In this question, we've been given some information about some carbon, and we've been told that there's 2.61 times 10 to the power of 24 atoms of carbon present. And what we've been asked to do is effectively work out the number of moles of carbon atoms present. How would we go about this question, and to what extent, if at all, would we need the periodic table to answer this question? Now, we've been given a very specific piece of information. We've actually been given the atoms present. It's not like we've been given a particular a mass, a number of like so and so number of grams of carbon. We've literally been told the exact number of atoms present. And so given that, when we ask ourselves, well, do we need to use the periodic table? I mean, carbon, you can see carbon here. Do we actually need this? In this specific case, because we've got the number of atoms in the question, rather than a particular mass of, a carbon sample weighing this amount, right? Actually, we don't need the periodic table to actually work it out, right? Because what we really need is the number of particles. In this case, the particle is atoms of carbon, and we have access to the Avogadro constant. So when we refer to the actual equation we would need in this case, well, originally we would be looking at, well, number of particles equals the moles, right? So the number of moles multiplied by the Avogadro constant, right? So or in other abbreviated as Na. In this case, we can also represent this as in the other form, right? So the particles and that's an A. It looks like an O, but that's an A. Avogadro constant, right? Na. Or should I'll actually, yeah, I'll do that as a capital A. Na. Right? Okay. And then we can, I don't know if this will fit, but we can kind of try and fit that as a pyramid, like, Okay, so in this case, if we actually try and work this out, and I would invite you to have a go, use the equation, try and work out what the answer is. But what we need to do here is we need to rearrange the equation first, right? So we're looking for this value. We've been given this, and we know that we've been given this, right? So therefore, to work this out, we're going to have to divide the number of particles. I'm just going to briefly represent this as P, and I'll just represent that as Na. So I'm going to just represent this number of moles as N, okay? So to work out N, which is what we're looking for, we're going to do P divided by Na, okay? So if we do that, that's going to be 2.61 times 10 to the power 4 divided by the Avogadro constant. Okay, so 2.61 times, times 10 to the power of 24, right? Times 10 to the power of 24 divided by 6.022 times 10 to the 23. So I would invite you to have a go at working out what that is, and if you do try that, what you should get is that is equal to 4.33410.827. And if we just check what what we've actually been requested to do with the value we get, it says give your answer to 2 decimal places and in standard form, right? Now in this particular case, because we've been asked for a number of moles, and as you can see, this is for a given number of moles, in this particular case, standard form is not relevant. We don't need to represent it in times 10 to the power of anything. What we do need to do is we do need to give our answer as requested to 2 decimal places. So what would that be in this case? In this case, that would be simply put 4.33, right? So that would be our answer in this case, 4.33 moles of carbon. And so we could just write moles of carbon atoms, right? Okay.